Hi everyone, I want to tell you today about how to use a burette and set up for a titration experiment. So the first thing that we're going to do is actually just talk about how to fill the burette. The first thing you want to do, as always, is make sure the stopcock's closed, otherwise liquid will just come right out. So get your titrant. Our titrant today is just some green liquid so that you can see it easily, so that it's easy to see in the video. But normally it'll be a clear liquid like sodium hydroxide solution. Sometimes we do other colored liquids. Today we've got green food color. So first off, you're going to pour it into the burette using a beaker, a small beaker, or you can use a funnel and pour into the funnel. Just be careful of overfilling like we talked about. One thing is I'm sort of tall, so it's easy, you can see it's easy for me to reach this, but if I wasn't tall at this height, then I would have a lot of trouble getting up there. You'd almost need to climb on top of something. So there's a couple things you want to think about. For a lot of people, and even for tall people, it might be much easier to actually remove it from the holder and actually just take it down to whatever level you're comfortable with when you're pouring in. So be thoughtful about a technique that works correctly for you, not just one that works for your teacher in front of the classroom. Also, be especially careful if you're sitting down and operating this that you don't hold it over yourself in any way where you're going to spill it onto yourself if you were to actually accidentally slip and spill. So still hold it out away from your body and add titrant one way or another. Whatever way you think you can do it the best. Try not to get any drops down the side of the beaker or down the side of the burette. All right, so when you do that, the first time you're just going to put sort of any amount in. I actually prefer to just fill it up well past the starting line. Burettes read, there are two deliver measurements, so they read from 0 to 25 how much liquid you've delivered into your container. So if you fill above the top, the first measurement is 0. So just fill somewhere near the top, it doesn't really matter, because the first thing you need to deal with is actually that this section, the stem of the burette, is actually full of air, and you need to get that all full of titrant. So if you adjust the burette down so it's just over the Erlenmeyer flask or the waste container, if you're just getting rid of the air bubble, you generally start with the waste container, and just open it to let it out. If you let it out slowly at first, you'll see, actually it didn't happen this time. You can see it actually there. There's just a tiny little air bubble there that's still in there, and you need to make sure that all of the air gets all the way out. So to do that, normally if you just open it wide and let it run, it goes out. But you see in that case, it didn't. So this is a good example. What you need to do for that is pull your waste container out over here and open the stopcock up and give it one quick jolt down. So while it's running, give it a quick jolt down and any air bubbles will travel out of the tip of the burette then. There's some other ways to do that, but that's the simplest for most people. If you have another way, knock yourself out. So now we're ready to go ahead and begin our experiment. So before you begin any titration experiment, before you take any initial reading, you want to make sure that you can see that the burette is closed, that there's no air bubbles in it, there's no hanging drops. If there are hanging drops, just touch it to the side of a container and you're all ready to go and you can take your initial reading. When you want ready to take your initial reading, you want to make sure that it's somewhere near the top of the burette, but not at exactly the 0 marking. There's all kind of errors associated with trying to start right at 0. So we really don't recommend that in any case. So start somewhere below 0. Between 0 and 1 is pretty typical. Between 0 and 3 is fine, as long as you have the majority of the burette still to use. So I ended somewhere between 2 and 3, and that's fine. So we're just going to go ahead and take our initial volume reading from here, and we're going to talk about how to do that. So first off, you need to make sure that you're looking right at the level with the air bubble, and we're going to try to make sure the camera is there too, so you're seeing exactly what I'm seeing. And you're looking at the bottom of the meniscus curve. Water will form this what's called a meniscus curve in glass, and you're going to see the bottom of the meniscus curve. If you're having trouble seeing exactly where that meniscus curve is, on this liquid it might be fine because it's green, but you can visualize it by actually bringing a colored line, black or red or any other color you want, up below the meniscus, and it actually, at a certain level, it sort of highlights the meniscus. We'll post another video where you can see this really well with a clear liquid, but there's a certain place that it actually reflects in the bottom of the meniscus, and you can actually visualize the bottom of the meniscus better. It works well in a green color with a red line, so you can sort of see that. So that can actually help really well. So now I'm going to go ahead and actually take this reading And we're having trouble getting a bit of focus here, so bear with us. Can you pull back a little bit? Okay, here you go. So we can see here that the reading that you're looking at, this one's 2 and this one's 3, and in between it's every 0.1. So 2.1, 2.2. The slightly longer line that you can see is 2.5. So here it's between 2.5 and 2.6. So the graduations, the markings on this measuring device are 2.5 and 2.6. And we're going to have to estimate, can you show them that there is actually another marking down there? Move down a little bit. And back up. Okay. Oh gosh, there we go. So it's between 2.5 and 2.6, and we're going to estimate how far between 2.5 and 2.6. And I think it's not quite half, so I'm going to call that 2.54. So it's between 2.50 and 2.60. I'm going to call it 2.54, and I'm going to write down 2.54 milliliters. And now, in my notebook, directly into my lab notebook, and now I'm going to have my lab partner actually come over and make another reading, just to show you that different people might see that estimate on the last digit a slightly different way. So go ahead and say what you think it is.
I think it's 2.56. I'll write that down in my book so we have both of them down.
Okay, so that's just a good example that you won't always get exactly the same reading. It doesn't matter. 2.54 or 2.56 is much better than just rounding off to 2.5 or 2.6 because it was not at exactly either one of those lines. So that's how you take a reading. That's the initial reading. And now you're generally ready to begin the titration. And there's one last technique that I want to show you before we actually begin a real example of a titration. And that's really how to add liquid to your titration experiment, to your Erlenmeyer flask in your experiment. So at the start of a titration, it's really simple. You just open the stopcock and let the liquid run out, and it's no big deal. But as you get closer and closer to the end point, you want to add less and less and less titrant. There's a lot of ways you can do that. You can just open it a little bit so you get like fast drops. But when you get right near the end point, you want to add the tiniest amount that you can per every use of the stopcock. There are different techniques. Hopefully we'll post a video later about some alternate ways to do this. There are lots of cool ways to do this. But I want to recommend this one way of doing it. And it's when you get close, you can add 1 drop at a time, and you just open slowly to add 1 drop at a time, real slowly until 1 drop starts to form. And then you turn it off and you've added 1 drop. Or to add even less than that, you can actually place your thumb under the stopcock and your finger on the far side and do 1 quick 180-degree rotation. You'll want to practice this before beginning an experiment, but you can actually add much less than a drop this way. It's weird. It doesn't look like so much less, so I'll show you a demonstration of how much less it is here right now. So for this first one, we're going to add 1 drop. We're going to slowly open up, and I'm going to put it back in the clamp so that it's easier held for me. And I'm going to open it up real slowly and just add 1 drop. Okay, so that's just 1 drop. And you can see about how much space it soaked up on the paper towel. So it gives you a visual example of about how much liquid was in that 1 drop. Now I'm going to move the paper towel over and do the quick drop method to show you about how much liquid is in, a quick half turn method. So if you do this, you just go 1 quick half turn, 180 degrees, and it's actually much less liquid than in that full drop. So that's one way, and it's so much faster too. I didn't have to slowly open the stopcock and take all that time. I can just very quickly add a much smaller amount of titrant. And it's a lot easier then to hit the final endpoint right on the color you want in a titration. So it does take skill to get that quick half turn. So practice that long before when you're rinsing the burette with DI water or something. Practice that technique to get really good at that quick half turn, and you'll be much better off overall in your titrations. If you really, really continue to struggle, stay tuned and we'll try to get another video. There's a lot of cool ways to do this, it turns out. So we'll try to get another option posted later.